about today is a little demo about the moment of inertia. To put things in perspective, the inertia, the regular inertia, not the moment of inertia, but the regular inertia is another name for mass, okay? The mass is, when you look in the textbook, it has all sorts of different definitions, how much of the object there is, but the mass is ultimately the resistance to the change in its motion, right? I am much more massive now, with the COVID-19, or 38 perhaps, but I am more massive than any of you guys, all right? So if I walk into this fast at 1 meter per second, right, and then somebody that's 5 foot nothing walks into you at 1 meter per second, you're going to find that it's much more difficult to stop me than it is this person who's 5 foot nothing, okay? And compare that to a car that's moving down at 1 meter per second, compare that to me. It's going to be much more difficult to stop that car because the car is much more massive than I am, and I am much more massive than this other person who's 5 foot nothing, okay? That's the inertia, the mass. Again, inertia is the resistance to a change in its state of motion, okay? There is a corresponding angular version of that. Let's call it the angular mass, right? More technically, it's called the moment of inertia, okay? Moments, just to put things in perspective as we get further into this, you'll see that there are moments, and moments always involve a distance from an origin. So it depends on where your origin is, and that's up to you, right, as the person who's analyzing the situation. My mass is my mass, regardless of your frame of reference or where I am. The moment of inertia, however, depends on which point you were talking about, okay? Let's look at this. This is a meter stick. I have 200 grams here. I have 200 grams here, so you can see what they look like. All right, nice and symmetric here. One's on top, one's on the bottom. It's to make it a little bit symmetric. And I take this object. Again, it's a meter stick. 200 grams here, 200 grams here, and I hold it with my hand here, and I turn it, and I just going to turn it as quickly as I can back and forth. Relatively easy to do, okay? I have here also a meter stick, okay? But I have the same mass, 200 grams there, 200 grams there on the outsides of the meter stick, okay? Now I'm going to do the same thing, and I'm going to turn it as quickly as I can. And you can see that I'm having much more difficulty with this than I was with the other. Let's try to do this with the two of them side by side. I'm not quite sure if I can pull this off without killing myself, but if I take this and go back and forth, and I take this and go back and forth, you can, and my left hand is much weaker than my right hand. Okay, the left hand is up here. This guy's flapping back and forth. The other one's I'm having much more difficult time making it move. Okay, the frame of reference there, if you saw, I was doing it here in the middle, right? I take the same object, but grab it here at the end, and I'm going to have a much more difficult time, okay? This moment of inertia, turns out it's the same object with the same mass. The mass is the same. The mass of this and the mass of this is the same. The inertia of these two objects are identical. The moment of inertias are not. The moment of inertia of this is larger than the moment of inertia of this, because obviously this resists change less than the other one does, okay? This has a relatively small moment of inertia. You see I'm able to rotate it back and forth very quickly. Just grab the end of it, and I have more difficulty. This moment of inertia, the same object, this moment of inertia is larger than this moment of inertia, simply because what I'm calling the origin is different. One origin was in the middle, one origin was on the side. Physics is fun.